All right, when we talk about a translation, we're talking about a horizontal and or vertical slide across the graph. By horizontal, I mean a left or a right slide, and by vertical, I mean up or down. If you have trouble remembering those, an easy way to remember horizontal, the word horizon is right in there. The horizon is kind of the crest of the earth that you see when you stare out across the distance. You can especially see it when you're out by the ocean. The horizon is the flat line across that you see out in the distance. If you have trouble remembering the word vertical, if you watch sports, when we talk about athletes having a vertical, it's how high they can jump. Especially at the NFL Combine, they measure an athlete's vertical to try to compare people. It's how high you can jump, so that's measuring a distance up and down. Translations can be talked about in a couple different ways. So we can say move left or right, up or down. You could say horizontal or vertical. And on the back we'll see that there's a way to write it with variables. On example 1, it's asking us to translate point B vertically -3 units. Vertically means up or down, -3 means we're going down. So we're taking point B and we're moving that 3 spaces down. 1, 2, 3. The new coordinates there are -5, that's the x, and +2. 5, 2. Number 2 says translate point C right 2 and 1 down. So translate point C right 1, 2 and down 1. Point C is going to end up there. That's at 0, 2. The x coordinate is 0 because we're not moving left or right at all. Number 3 says translate the point E, a vertical shift of 5. That's up 1, 2, 3, 4, 5. That's the point 3, 1. Alright, pause the video, do the next 2 on your own, and then continue with the video. On the back, we're going to be talking about moving the whole shape. So instead of just moving one individual point, we're going to be moving, in this case, 3 points, because we're going to be talking about the vertex, or the vertices of the entire shape. So we're going to be talking about these 3 corner points. We want to figure out where each of those is going to end up, and then really just connect the dots so that we can make the same shape, just in a different spot. We're moving 4 units to the right and 2 units up. So I'm going to take each of those points and move them 4 units to the right, 1, 2, 3, 4, and 1, 2 up. So N is going to end up there. I'm going to call that N prime. D is moving 1, 2, 3, 4, 1, 2 up. So that's D prime. And W, 1, 2, 3, 4, 1, 2. That's going to be W prime. So you can see once we move all the corners, you really just need to connect the dots, and it reforms that shape in the new spot. This question is actually asking for the coordinates, so we're just going to record out each of those coordinates. That's 0, -3. That's point W, or W prime. D prime is at 1, 2, 3, and then down 1, so 3, -1. And N is 2 below that, so it's at a +3 and a -3 as the Y coordinate. This one's asking for a horizontal shift of 1. A positive horizontal shift means we're going to the right 1. And a vertical shift of -2, that means we're dropping down 2. Horizontal shift of 1, W will end up here, and then down 2, it'll finally end up down here. C will move over 1, down 2, and F over 1, down 2. The question's asking for F prime. So this is going to be the new shape. But we're asked about F prime, and we're asked what quadrant is that. The first quadrant is here, then it makes a big C. So it's 1, 2, and 3. Alright, so this is the trickier way that we're going to see this, and it's really saying the exact same kind of thing that I was saying before. It's just putting it with a variable, and all this is saying is that we're going to take the original x coordinate and we're going to add 1 to it, and we're going to take the original y coordinate and we're going to subtract 2 from it. Okay, so really this is saying exactly what I was saying before. It's saying add 1 to the x value. The x coordinate is left or right, so adding 1 means really we're just going to the right 1. And subtracting 2 from the y. The y is up and down. Subtracting 2 means we're going down 2. Okay, so we can think about it that way, or we can actually just look at the coordinates. We can look at the original coordinates, 0, 0, 0, 3, and -4, 0. Those are the original 3 coordinates. And we can really just do these operations. We can add 1 to the x. So for each of those coordinates, we're going to add 1. You add 1 to 0, you get 1. You add 1 to -4, we get -3. And then we subtract 2 from the y. That gives us -2, 1, and -2. Just subtracting 2 from each of those y coordinates. So again, we could think about that either way. We could translate it into words. Really, all it means is right 1 and down 2. Or you can actually perform the operation on each of the coordinates. Either way, it would lead us to this new shape. And with the new coordinates of b prime, p prime, and q prime. Alright, so I'm going to do one more example like that. You're going to answer this question, and you're going to do the next 2 examples. I'm going to do this one, and you're also going to answer this question here. Alright, so we're going to do this the exact same way we just did it. We're going to do it actually both ways. We're going to interpret this. Subtracting 7 from the x value means we're moving to the left 7. The x value is talking about left and right. If we're subtracting 7, we're moving 7 to the left. We're adding to the y value. That means we're going up 2 spaces. So we can move the shape and then look at the coordinates that way. Or we can take our old coordinates. These are the original coordinates: 2, -1, 5, -1, and 5, 3. And we can subtract 7 from the x coordinate and add 2 to each of the y coordinates. Both would leave us with that picture. Alright, so like I said, continue with these 4 examples on your own, really these 6 questions on your own, and then continue with the video. Alright, so here we're going to be working backwards. Given the translation from these original coordinates, this x, y, and z, to x prime, y prime, and z prime, what happened? Basically, what was the translation that occurred? So we're going to be writing each of these with the rule that we just learned, where we show it as an operation that's happening to the x and the y coordinate. So really what we're looking for is what's changing going from the x coordinate of each of these original points to the new ones. So going from 1 to -2, 6 to 3, and -4 to -7. I think it's easiest to see on the 6 to 3 because those are positive. We're subtracting 3 from each of those x's, and you can confirm that with each of the other ones. So that's how we're going to write that. The x is dropping by 3. We're subtracting 3 from each x value. For the y coordinates, we're going down from -4 down to -6. We're again subtracting. Again, it might be easiest to see on the positive value, going from 2 to 0. We're subtracting 2, so it's y minus 2. That's the translation rule. On example 2, we're looking at those x values, and they're actually exactly the same. Going from -5 to -5, nothing really changes, so we're not going to do anything to the x value. We're going to leave that exactly the same. And from the y values, it looks like we're going down from -4. We're going down to -8. That's dropping 4. Again, the positives might be easiest to see. Going from 6 down to 2, we're dropping 4. So we're subtracting 4 from each of the y values. When we're looking at a picture, we're looking at what's changing in the x values. So I would just pick one of these to look at. I'm going to look at point A. It's starting at -7 in the x direction, just -7, and going up to 3. So I know it has to jump 7 to get to 0, and then it's got to jump 3 more. So 7 plus 3, that's adding 10. It's jumping 10 to the right. Then it's starting at 3 in the y direction and going down to -4. So it's dropping 3 and then 4 more, that's 7 total. So we're subtracting 7 in the y direction. That's how we would write the translation rule. All right, finish this practice on your own.